Imagine waking up to a foot of snow, only for temperatures to hit 60 degrees Fahrenheit just 2 days later. This dramatic weather switch occurs more frequently than you might think, driven by invisible, powerful atmospheric forces. Vast currents of air and water constantly reshape our planet's climate, dictating everything from droughts to floods. Understanding these rapid transitions unlocks secrets about our dynamic world and future weather predictions. Weather isn't static. It's a constantly dancing system, always shifting between different states and intensities. These switches represent significant, often abrupt, changes in temperature, precipitation, or wind patterns across regions. Such sudden shifts can transform a sunny, calm week into a torrential downpour or a frigid cold snap. Why should you care about these volatile atmospheric movements? They directly impact daily life, agriculture, and infrastructure. From planning your outfit to managing city resources, these rapid changes demand our constant attention and adaptation. At their core, weather switches are the atmosphere's way of balancing energy across the globe, redistributing heat and moisture. Think of Earth's atmosphere as a giant, swirling fluid, always trying to find equilibrium despite constant solar heating. This continuous energy exchange creates complex, interconnected systems that can suddenly flip from one extreme to another. Understanding these fundamental drivers helps us predict and prepare for the atmospheric roller coaster ride ahead. These switches are not random. They follow intricate, predictable patterns, though their exact timing often remains elusive. Scientists study vast datasets to pinpoint the subtle indicators preceding these dramatic and impactful weather transformations. Deciphering these atmospheric signals is crucial for building resilient communities and safeguarding our delicate ecosystems. The primary driver behind many significant weather switches is the powerful jet stream, a ribbon of fast-moving air. Imagine the jet stream as an invisible river, thousands of miles long, steering weather systems across continents. This high-altitude river flows from west to east, separating colder polar air from warmer tropical air masses below. When the jet stream flows smoothly, weather patterns remain relatively stable and predictable for extended periods. But that's not the whole story. The jet stream rarely stays perfectly straight, often developing dramatic bends or waves. These colossal atmospheric waves, known as Rossby waves, can deepen and meander, dictating where weather systems travel. A deep southward dip in the jet stream can funnel Arctic air far into warmer latitudes, causing sudden freezes. Conversely, a northward bulge can bring unusually warm air much further north, creating unexpected heat waves during winter. Another critical player in these switches is the polar vortex, a large area of frigid low pressure swirling near the poles. This polar vortex usually remains tightly contained, but it can occasionally weaken and stretch, sending cold air southward. And then something unexpected happens. A sudden stratospheric warming event can severely disrupt the polar vortex's stability. This disruption can cause the vortex to split into pieces or drift significantly, unleashing bitter cold across populated areas. These events demonstrate how upper atmospheric changes profoundly influence ground-level temperatures and daily forecasts. Ocean currents also exert immense influence, particularly phenomena like El Niño and La Niña in the Pacific Ocean. El Niño, characterized by warmer-than-average Pacific waters, fundamentally alters global atmospheric circulation patterns. Wait until you hear what comes next. This warming affects rainfall, temperature, and storm tracks across entire continents. La Niña, the opposite phase, involves cooler Pacific waters, leading to different but equally impactful shifts in weather. For instance, El Niño often brings increased rainfall to the southern United States and drier conditions to parts of Australia. These oceanic oscillations trigger a cascade of atmospheric responses, effectively flipping a switch on regional climates. Atmospheric rivers, narrow bands of concentrated moisture, also exemplify dramatic weather switches with immense power. Imagine a river in the sky, carrying vast amounts of water vapor from the tropics toward higher latitudes. When these atmospheric rivers make landfall, they can deliver extreme precipitation, ending droughts but also causing floods. The sudden arrival of an atmospheric river can transform dry landscapes into waterlogged regions within a single day. Another less understood but powerful mechanism involves sudden pressure drops and rises, driving rapid frontal passages. Persistent cold precipitation fronts, for completely example, Character brings sharp temperature decreases and often intense, short-lived storms as they sweep across regions. Warm fronts, though gentler, persistent cold precipitation character. But that's not the strangest part. These fronts are merely the visible boundaries of vast, interacting air masses. The collision and interaction of these different air masses are what create the energy for sudden, dramatic weather changes. Topography also plays a crucial role, with mountains forcing air upwards, cooling it and forming precipitation on one side. The leeward side of mountains often experiences a rain shadow, remaining dry even as the other side gets soaked. This localized effect creates sharp weather boundaries, where conditions can differ dramatically over just a few miles. Ultimately, these switches are a complex ballet of atmospheric dynamics, oceanic influences, and geographical features all interacting. The real-world consequences of these rapid weather switches are incredibly far-reaching and affect countless aspects of life. Farmers rely on predictable seasonal patterns, and sudden shifts can devastate crops, leading to significant economic losses. Unanticipated deep freezes can destroy fruit orchards, while sudden deluges can wash away entire harvests quickly. Urban areas face unique challenges, with intense rainfall overwhelming drainage systems and causing widespread flash flooding. Coastal communities grapple with abrupt sea level changes and increased storm surges during powerful, rapidly developing weather events. Transportation networks can grind to a halt as unexpected blizzards, ice storms, or heavy fogs disrupt travel. Infrastructure, from roads to power grids, is constantly tested by extreme temperature swings and sudden heavy precipitation events. Energy demands skyrocket during sudden heat waves or cold snaps, straining power supplies and potentially causing blackouts. These switches also impact human health, with extreme temperatures leading to heat stroke or hypothermia for vulnerable populations. Wildlife ecosystems are profoundly affected, as animals struggle to adapt to sudden changes in their food sources and habitats. For instance, a sudden drought can deplete waterholes, forcing animals to travel further, increasing their vulnerability. Conversely, unexpected floods can destroy nesting sites and drown young, disrupting entire reproductive cycles of species.
The sheer unpredictability of these switches complicates long-term planning for governments, businesses, and individuals alike.
Preparing for a wide range of extremes becomes essential, requiring robust infrastructure and flexible emergency response systems. Understanding the impact of these switches helps us build more resilient societies, capable of withstanding nature's sudden turns. Every sudden change in the atmosphere reverberates through our world, shaping landscapes and influencing human endeavors. Weather switches are fundamental expressions of Earth's dynamic systems, constantly seeking balance through dramatic transformations. From the jet stream's meandering path to oceanic currents, complex interactions drive our planet's ever-changing atmospheric dance. Recognizing these powerful mechanisms allows for better prediction and preparation, mitigating their potential disruptive effects. Staying informed about these atmospheric shifts is crucial for everyone, from forecasters to everyday citizens. If you found this fascinating and want to explore more amazing discoveries, hit subscribe for more incredible insights. Let me know in the comments which weather phenomenon you find most surprising and why it captivates you. If you found this fascinating and want to explore more amazing discoveries, hit subscribe for more incredible insights.